Yeah, thank you so much for doing this. I know you're working on this tool called Reducto, so I wanted to get a high-level understanding on platform, and maybe if you can start off with your background and the idea behind creating this platform would be a good start.
Yeah, absolutely. So I'm Adit. I'm one of the co-founders of Reducto. My co-founder and I actually met at MIT. So we had a long history of working on ML projects. And after graduating, we were doing some RAG consulting. So helping enterprises connect their data to LLMs. And through that process, we realized that one of the hardest things for doing that is actually not all the like model fine tuning or anything like that. It's actually just being able to extract the information that's locked inside these unstructured PDFs. So we tried pretty much everything on the market and it just wasn't accurate enough for us. And after a while of just plugging through and hacking our way on top of other solutions, we decided to just build our own. And so that's actually what Reducto is. We set out to build the most accurate PDF ingestion on the market. And so now we have a solution that a lot of enterprises and startups are using to power their RAG or other LM workflows.
So your USP here is PDFs, unstructured documents, which has complex structure in some cases, tables, diagrams, text by itself. So that's the
Yeah,
USP.
that's right.
Okay. Okay. So let's get started. So if you want to, walk me through the product and what a typical user would do into getting the outputs from the solution.
Yeah. I mean, we are an API. So we offer APIs for either general document extraction or also for structured extraction. But we have this playground that you can take a look at. This is publicly available if anybody wants to try it. But basically, we decided to take a vision-based approach to understanding documents. So the thing that we are exceptional at is for any given layout, no matter how complex it is, we have a very good understanding of where on the page everything is and what it is, whether it's a title, whether it's a section header, text, table, image, and so on. And once we have that classification, we're able to go through and use a very specific pipeline for each. So the text, of course, we can extract the text associated with the section that it's from, but also with things like images, for example, we can go through, we can use a vision model to create embedding summaries that you can throw into your vector database and retrieve when it's relevant in the future. We do the same thing with graphs, for example, where if you have a bar graph, we have a pipeline that'll quite literally go through and measure each bar relative to the axes to understand the underlying data from it. And that way your LLM can respond, not just on is there a bar graph in this document, but exactly on questions of trends and things like that. So what we do is we go through for the RAG use case, we'll create these optimized chunks that you can feed into your vector DB. You can see that there's a lot of little details here. For example, where we chunk this section, but we make sure to include the added context of the original section that it was from. And that way, no matter which chunk is retrieved, there's always the relevant information that you need. And we do this across things like lists, where we'll use the positional understanding to know that a is a subclause of two that's tabbed over, and we'll maintain that hierarchy. Or even for really complex things like these tables, we work with a lot of people in insurance and finance where they have tables that might not have grid lines, might have merge cells. In this case, there's a lot of empty cells that makes it really hard to extract the structure. But I can just show you, I believe this is the table, what this would look like in its HTML structure. We chose HTML because LLMs have been trained on a lot of HTML. And so in our testing, this is actually the most accurate way to find information about a table. So again, no matter the type of table, the type of list, or any other concept that you come across, we're able to extract that accurately. And now we're using our really accurate document processing to also power other features like if you have contracts, we can automatically extract information about each line item, things like that.
Okay. About vision early on while you were showing this.
Mm-hmm.
And is this vision limited to tables, graphs, or let's just say I have a PDF which has some building architecture. These architectures are about how aerial view of a typical building would look like, and there are some problems that specific. Uh, let's just say you have a PDF, and that PDF is probably 2 3 years old, and that document specifically solved a real estate problem. And fast forward 5 6 years, we know that back in days we solved a problem and we don't know where exactly it is. If I throw
Sure.
documents of that sort into Reducto, can Reducto scan through all my documents from a layout plan perspective? If I ask questions, would it be able to find, hey, in 2016 you solved a similar problem, and this is the aerial view of that architecture, and this is the solution for that. So anything of that sort with this vision in mind?
Yeah. So to be clear, we do the document ingestion stage, but we aren't building like full chatbots. But our customers can absolutely power use cases like that. So in a case like that, there's a few things that we would do. First, like we would break down that building architecture documents, and we'd be able to identify exactly where the section is. We offer the option to add custom prompts for figure processing. So in the case of architectures, the same way you would query with GPT-4b, you can say that like the images might include aerial imagery of documents and like extract details that involve X, Y, and Z. And so in that case, the summary that you saw earlier, which was a picture of space, would instead have more specific information from this architecture context. And you'd be able to know exactly which page that's on, and the exact section of that page with the bounding box that retrieved image is in. And of course, from there, you can extract that image, answer a user's query, and so on.
Yeah, that's helpful. So let me ask you this. From a model, let's talk about,
because we are focused on this like really complex document workflow segment. People use us for things like RAG and summarization, of course, but also for the things that otherwise you would have needed to have entire teams of people reviewing documents and manually entering. So they might use us to like automatically extract information from invoices, things like benefits documents, and so on.
This is great.
Let's go.
Thank you so much. Appreciate your time, and this is helpful. Thank you so much, Adit.
Yes.
Bye.
Yeah, bye.